Cougars, this is Teresa Miller. Hope you guys are all safe and well. We're going to be doing the 8-7 intro. 8-7 is on factoring, which is how do we break something down to its simplest ingredients. It's kind of like if you went to a restaurant and you were eating this delicious pasta with the sauce on it, and you're like, my gosh, this sauce is amazing. What are the ingredients in this? My mom has this uncanny ability to tell you every bit of what's in it without looking at the recipe. We're going to learn how to do that when it comes to polynomials. So we're going to look at this polynomial, we're going to examine it and go, what are the basic ingredients that would have made this? So that's our job. So let's do a little review. I know that we covered these. Let's see if you remember what it's called. Do you guys remember what that's called? That was called a conjugate binomial. It was a binomial, 1, 2, times another binomial, 1, 2, and they were exactly the same, but they had different signs. And conjugate binomials, when we multiplied them out, something really cool happened. So I'll use FOIL to re-examine this. So front, outer, inner, and last. And we can see clearly that the middles cancel. There's nothing left there. And we're left with this first term, 9x squared, and the last term, which is -4. So when we multiply conjugate binomials, same stuff, different signs, we get this beautiful thing that's called a difference of squares. Miss Miller, why is this called a difference of squares? Well, one, it has a difference in the middle. There's a subtraction sign. And you have squares on both sides. You literally have a difference of these things being squares. So today's lesson, part of today's lesson, is taking this 9x squared minus 4. That's your question, and you got to tell me, hey, what created that? What are its simplest ingredients? So I think one of the easier ways of doing it is to go, okay, well, let's see if it's a difference of perfect squares. Do I have a perfect square number in both the front and the back? Well, yeah, 9 is a perfect square. 4 is a perfect square. X squared is, in fact, a square. And is there a difference in the middle? Is there a subtraction sign? If you said yes, you have a difference of perfect squares. So maybe printing out a multiplication chart for most of you would be very handy. You can see the squares are right on the diagonal. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And so on. We're going to use these to help us identify a difference of squares. So let's put that over here. So here's what I do. First, I'm using a different color. I'm like, what two numbers would give me 9? Well, that would be 3. What two numbers or what two letters give me x squared? That would be x. So the square root of this is 3x, and the square root of 4 is 2. So if we looked at our multiplication chart, 9 is 3 and 4 is 2. And how do we come up with our final answer? We take that and that. So we know that 3x goes in the front, 3x goes in the front. We know 2 goes in the back. And because this is a difference of perfect squares, we know that we started with conjugate binomials. That means one is plus and one is minus. Doesn't matter which one you make minus and which one you make plus. No, that doesn't matter. It's up to you. So let's try to put this in action. Let's go to your notes. So please have those printed in advance. The 8-7 notes. And we're going to look at the first batch of questions. Great. So we can see the first question on our notes is 36 x squared minus 25. That's question number 1 on our 8-7 notes. Well, first of all, let's Let's see if this is a difference of perfect squares. Let's see if it meets the qualifications. Is there a subtraction sign in the middle? Yes. Is 36 and 25 a perfect square? Well, if we look at our multiplication chart, 36 is and 25 is. And is this a square? It is. So the work that I would want to see from you is right above this. What is the square root of 36? 6. What's the square root of x squared? X. What's the square root of 25? 5. That's the work I'm wanting to see. Now we set up our parentheses. We know that 6x goes in the front. 6 times 6 gives me the 36. X times x gives me the x squared. And in the back are 5s, because 5 times 5 gives me that 25. And we know we're going to have conjugate binomials. So this thing in black is my answer. It is what I could multiply to go back to that purple difference of perfect squares. Go ahead, and I'm going to stop the video here, and we'll do another video starting with question number 2.